Hello, this is a video to demonstrate the use of an oscilloscope and current clamp to do a relative compression test on any internal combustion engine. This method is easier, quicker and involves less risk of damage than a traditional compression test. You will need the following: 1. An oscilloscope and computer, 2. A high amp current clamp, and 3. A nice secure table to keep all your equipment on. Firstly, you need to connect your current clamp to your oscilloscope. Connect the current clamp into the oscilloscope and set the voltage scale according to your current clamp's output. The current clamp we're using has an output of 1 millivolt per amp, and as a gasoline engine has a typical starting current draw of between 80 to 200 amps, and a diesel engine has a typical starting current of between 2 to 300 amps, it is best to set your voltage scale at 200 millivolts DC for gas and 500 millivolts DC for diesel. So we're going to go ahead and we're going to set this 200 millivolts on our voltage range. It's set to DC, and we have 200 milliseconds per division on our time base. You may need to alter this slightly for a faster or slower cranking engine. And now we have to zero the current clamp, and we do that with the zero knob in the bottom corner. We actually adjust this to make sure that the trace across the center of the oscilloscope screen is absolutely on zero. Now we have to set a repeat rising edge trigger. So we set repeat. We're already on rising edge here. It's on channel A, which is the channel that the current clamp is connected to, and we are just going to move the trigger back to 10% so we can see the rest of the waveform on the screen nicely. And for a voltage value, we're going to set 100 millivolts, which equates to 100 amps. Now you need to locate the battery to starter motor positive lead where it connects into the battery, which is this lead here, and the current clamp has an arrow with a positive symbol inside the jaws. You have to make sure this arrow is actually pointing away from battery positive. If you connect this the wrong way round, the oscilloscope trace will be inverted. Connect it and make sure the clamp fully closes. Now you need to either locate the fuel injection relay, fuse, or take out the coil pack plug to ensure the car will not start. Then you need to make sure that it's safe to crank the car. The current clamp and its wire are not going to get caught. Now you can crank the car and observe the waveform on screen. Now you see the initial spike in the current draw. This is to get the engine moving and overcome the friction of the engine. This is normal. This little hump here is from when the starter solenoid kicks in. And then it settles down into a series of regular humps and troughs. The humps are for the current draw required to push each cylinder on its compression stroke. If the current draw for each cylinder is equal, then you have good compression on all cylinders relative to each other. If one of the peaks is missing or significantly lower, then you have low compression on one of the cylinders. To discover which cylinder is missing, you could then go up and connect up the injector signal or coil signal from cylinder number 1 to the channel B, and using the firing order of the engine, work out which cylinder has low compression. Or of course, you can do a traditional compression test and discover the dead cylinder. Hopefully doing this quick test can save you the bother of doing a traditional method if it is not required. It also involves less risk of breaking components such as spark or heater plugs when connecting a traditional compression gauge. If you require any further information, then please visit the Pico Auto website. Thank you very much.